Let's take a fun journey through the fascinating world of brain chemistry and health. Imagine a brain as a bustling city where tiny messengers called neurotransmitters like dopamine, serotonin, and glutamate are busy delivering signals to keep everything running smoothly. Now, no one of the star players here is dopamine, a chemical that's not just about pleasure and reward, but also plays a crucial role in movement, motivation, and cognition. Dopamine is produced in nerve cell bodies located in the substantia nigra, a tiny but mighty region deep in the brain. From there, dopamine neurons send their terminals into the striatum, a key part of the basal ganglia, where dopamine helps regulate movement and behavior. Think of these neurons as delivery trucks synthesizing dopamine from the amino acid tyrosine, using a special enzyme called tyrosine hydroxylase. Once dopamine is made, it's packed into vesicles and released into the synapse, where it transmits signals to neighboring neurons. Afterwards, it's taken back up by dihydroxyphenylalanine transporters ready for reuse. That's neurotransmission at its finest. But what happens when these systems go diary? Sometimes dopamine dysfunction can throw the brain off balance, contributing to conditions like Parkinson's disease, where the degeneration of neurodopaminergic neurons leads to tremors and movement difficulties, or schizophrenia, which involves altered striatal dopaminergic functioning, affecting perception and behavior. Interestingly, iron plays a pivotal role here too, needed for dopamine synthesis as its cofactor for tyrosine hydroxylase. Proper iron homeostasis is vital. Too much iron can cause oxidative stress and neurodegeneration, while too little may impair neurotransmitter production and immune function. Speaking of iron, it's a busy transporter in the brain, crossing the blood-brain barrier with help from transferrin receptors and specialized cells called astrocytes, oligodendrocytes, and microglia. These cells work together to maintain iron balance using proteins like ferroportin, hephaestin, and ceruloplasmin to regulate iron uptake and efflux. Proper iron levels ensure healthy myelin production, supporting efficient nerve insulation and quick interneural communication. When myelination is dysfunctional, think defective myelin sheaths or demyelination, neural signals slow, affecting processing, communication, and overall behavior, which can manifest as cognitive, sensory, motor, or affective symptoms. In the grand scheme, everything is interconnected. Redox balance the oxidative phosphorylation, keep the energy flowing, support neurotransmitter synthesis, cellular metabolism, and neurodevelopment. Disruption here can lead to neurodegenerative disease like Alzheimer's or Parkinson's, where iron overload or deficiency, oxidative stress, and mitochondrial dysfunction play starring roles. So whether it's maintaining the dose of dopamine in the basal ganglia, ensuring iron gets where it needs to go, or keeping myelin healthy for sharp thinking movement, your brain's health depends on the finely tuned orchestra of cellular process. Remember, sometimes a little iron can go a long way as long as it's balanced just right.